the application of the laws of indices, which we have discussed in the previous class. We are looking at how we can use them or apply them in solving these problems that are here. All right, in the last class, we have been able to look at the introductory aspect of the laws of indices, and it was best explained. So I'm asking you or requesting you to check out that class so that you can be able to follow the application here in this class. All right, let's quickly look at it. We have a question here that says 27 over 125 raised to power minus 1 over 3 times 4 over 9 raised to power half. Now, the way out, like I used to say, that in any mathematical problem, you look out for the access point through which you can be able to assess that problem in order to resolve it. If you look at this now, you see that I need to change this 27 to its index form and also change this 125 to its index form. And when I do that, of course, 27 is the same thing as 3 raised to power 3, okay? And 125 is the same thing as 5 raised to power 3. They are all raised to power minus 1 over 3. Okay, I will not jump any step for the purpose of clarity. All right, if you look here, you realize 4 and 9 all raised to power half. And we have in the last class discussed among the laws of indices that any term raised to power half is equal to the square root of that number or that term. So we have shown that. So I can take the square root of, in this problem, 4 over 9. And of course, you know what that is going to give us. So right here, can you see that these are sharing equal powers? So we can have 3 over 5 all raised to power 3. And there is already existing power there, which according to the product power law says that if a term in index form is raised to another power, it is equal to the product of their powers. So we are going to multiply this and minus 1 over 3. I'm sure I am not too fast in that explanation. The square root of 4 is 2, and the square root of 9 is 3. Okay? So can you see that this 3 can remove this 3, and we have 3 over 5 raised to power minus 1. Okay? Then times 2 over 3. Of course, you know the reciprocal of 3 over 5 is 5 over 3. So we are going to have here as 5 over 3, then times 2 over 3. And that is going to give us what? 10 over 9. Of course, if you want to change it to mixed fraction, that's 1 whole number 1 over 9. Okay. Okay. So that is that. I'm sure you understood how this became this. This is the reciprocal of this is this. I mean, when you say reciprocal, 1 over something. Okay. So like 5, 1 over, the reciprocal of 5 is 1 over 5. So, and the reciprocal of 1 over 5 is 5. So the reciprocal of this 3 over 5 raised to power minus 1 over minus 1 is 5 over 3. Please understand that. Okay. So this is the explanation for this first example we have there. I'm sure it is clear. So the second one that says 3 raised to power n minus 1, okay, times 27 into n plus 1 all over 81 to power n. So there's nothing to worry about on this, but this we have to touch it a little bit, okay, so that the base have to be equal. So over there we are going to have 3 to power n minus 1 multiplying 3 to power, this is 3 raised to power 3 is 3 times 3 times 3 will give you 27. So, and you know this power is going up there to multiply the already existing power, which is n plus 1. Okay, all over, this is 81, and 81 is 3 raised to power 4. So, and that 4 will multiply this n. and give us, we will now have 3 raised to the power 4n. Do you get? If you want to check how to break that down and get what you're looking for, write 81. The only thing that can divide it is 3. 3 into 81 will give you 27. 3 into 27 will give you 9. 3 into 9 will give you 3. 3 into 3 will give you 1. So have how many of them? 1, 2, 3, 4. So that's 3 raised to the power 4. Okay. So having done this, having got this now, we can be able to open this bracket here, and we are going to have 3 to the power n minus 1, then times 3 to the power 3 times 3 will give us 3n, and then 3 times 1 will give us plus 3. This is all over 3, or permit me to rewrite this as, the whole of this as divided by 3 to the power 4n. Do we get that? So that by the time due to product here, multiplication here, we add their powers. So we're going to have 3 into n minus 1, then plus 3n plus 3. If this is division and we are to put minus here, please enclose this in a bracket so that when that minus enters here, it can do some touches here. Please take note of that. So then, because of this division, we are going to say minus 4n. So what do we have left? We have 3 to the power, this is n, and this is 3n, and this is 4n, okay? And this is minus 1, and this is 3. So minus 1 plus 3 will give us a plus 2, okay? Then here, minus 4n. So 4n minus 4n. I'm sure you understood my collecting the like terms here. This is n, this is 3n, that gave us 4n. This is 3 minus 1, that's 2. And this is, you bring down minus 4n. So this will take away this. And what do we have left? We have 3 raised to the power 2 left, which is 9 as a result. Okay, I'm sure that explanation is also taken. Let's quickly look at example C. In example C, we have 3 root 8. Okay, then a raised to the power minus 6. How am I going to present this now? I will rewrite it as 8, then multiplying a raised to the power minus 6, all raised to the power 1 over 3. All raised to the power 1 over 3. Okay? No. Now, can you permit me to rewrite this as 8 to the power 1 over 3, then multiplying a to the power minus 6, then all to the power 1 over 3, because this power and this power belongs to both of them. I'm sure that is clear. So, here, this is 2. I'm just trying to be detailed. Okay? So, this is 2 raised to the power 3, multiplying 1 over 3. Then times, this is a raised to the power minus 6, multiplying 1 over 3. So, you see that here, what is remaining is just 2. Times here, 3 cancel itself 1, cancel here minus 2. So, we have a raised to the power minus 2. So what do we have here? We have 2. This is comma. We have this 2 multiplying. This is now 1 over a squared. So finally, our result is 2 over a raised to the power 2. So I'm sure that is very, very clear. I'm sure that is very, very clear. I'm sure that explanation is very clear. Okay. Let's look at this last one. This last one that says this last one says 1 over 3 to the power 5n. Hope you're following what I'm doing here. Okay, times 9 to power n minus 1, then times 27 to power n plus 1. Okay, so you realize that we have to, you know, look out for the best way to assess uh, this problem. We look at for the best way we can be able to assess this problem. All right. Um, Based on what I have been saying before, you realize that what we need to do here is we try to change this to their index form. Okay, we try to change this to their index form, and then so that this is 9, this is 27, they can have the same index as these three. By the way, you know what the meaning of this is. I can rewrite it as 3 to power minus 5n. I'm sure it doesn't pose any problem from negative index law, which we discussed in the last class, times this is 3 to power 2, that's 9, is 3 squared. Okay, then multiplying n minus 1, then times this is 3 to power 3, multiplying the existing power there, n plus 1. Okay, so you can see that they are all products. So that is to say we can add their powers. Okay, so if we have this, we can say let this be 3 raised to power minus 5n, and over here, open here, you have plus. Of course, this will be 2n, and this will be minus 2. Then plus again, because of this multiplication, okay, we are going to add this. But before then, we try to open that bracket there. All right, so this will be 3n, then plus 3. So we can gather these powers now and check out what they are. Can you see that here 2n plus 3n will give us 5n, and of course when we have 3 to the power minus 5n, this will become plus 5n, and this is minus 2 and 3. Minus 2 and 3 will give us plus 1. All right, you see that this will take away this, and what do we have left? We now have 3 to the power 1 left, and what is it? It is just 3. So I think that is our answer. So this is the first set of examples we are looking at in problems resulting from indices. This is the first set of problems. Now I'm going to move on a little bit. I'm going to step up a little bit now. To having discussed this, now the next level I'm going to look at now is exponential functions. Yeah, let's go down to exponential functions, and from there we go to, yes, another class on exponential functions, then down to indical equations. Okay, please, you have to follow this class so that you can be able to get all this and stay good.